Database state. In a database, there will be a number of relations. Each relation will have many tuples in its state. The database state is basically the union of all the relation states. And whenever the database is changed, the database state is also changed. What are the operations that causes a change of database state? There are three possible operations that can change the database state. Insert, when a new tuple is inserted in a relation. Delete, when we delete one or more tuples from a relation. And modify, basically the update, when we change the values of one or more attributes of an existing tuple in a relation. So insert, delete, update. These are the three basic operations that changes the state of the database. This is some sample database state. Now we need to be careful that whenever the database state changes due to these three operations, insert, delete, update, the integrity constraints should not be violated by these operations. The database state must always be a valid state. Valid state meaning all the constraints are satisfied, and when the database state changes, it should go from one valid state to another valid state. So anytime these operations are taking place, the DBMS needs to ensure that the integrity constraints are not being violated. Let's look at the insert operations. Due to an insert operation, which constraints may potentially be violated as a result of the insert operation? We looked at four different constraints. Let's start with domain constraints. Can insert operation violate a domain constraint? It's possible. So let's say we have the student table where the student ID is an integer. If someone tries to insert a new tuple with the student ID value ABCD, there is a violation of domain constraint because why? Student ID can only take integer value, ABCD is not an integer. So insert operation may cause violation of domain constraint. What about key constraint? Key constraint means the primary key must be unique. But if the user tries to insert a new student with a duplicate student ID, then this will violate key constraint. Okay, what about entity integrity constraint? This constraint states that the primary key cannot be null. But if a user tries to insert a new student with student ID null, then this will cause a violation because the student ID is the primary key, it cannot be null. And referential integrity constraints, can insert operation violate that? Let's take an example from the schema that we saw before. So let's say currently in the company there are 5 departments. So in the department table we have 5 tuples, D number 1, 2, 3, 4, 5. And let's say the user is inserting a new employee in the employee table, and for the D number attribute, he inserts value 6. In the insert operation in the employee table, the value for D number attribute is given as 6. But 6 is not a valid D number, right? Because why? There is no D number 6 in the company. There are only 5 departments. And as we know, the referential integrity constraint states that the value of the foreign key must be an existing value of the primary key it is referencing. So if the user is not careful, then the user may try to insert an invalid value for D number, which causes referential integrity constraint violation. So therefore, insert operation may cause a violation of all 4 constraints. So now what should the DBMS do if the insert operation is causing such a violation? The DBMS should simply cancel that insert operation, meaning the insert operation will not go through. Because if the insert option goes through, then there will be a constraint violation, the database state will become invalid, and the railway state is never allowed to become invalid. It must always be valid. So whenever the insert operation is taking place, the DBMS checks for all these 4 constraints. If there is no violation, then fine, the insert operation goes through and the data is inserted. Otherwise, the insert operation is cancelled. It does not go through. And an error message may be displayed to the user that something went wrong. What was the error message? It can be shown to the user. Now, let's take a look at delete operation. Delete operation can only violate referential integrity constraints. Why is that? Delete does not violate domain constraint because you are not adding anything. So not possible to violate domain constraint. Similarly, key constraint cannot be violated in delete because you are not adding anything, so you cannot have duplicate key. Entity integrity constraint also cannot be violated in delete because in delete you either delete the whole tuple or nothing at all. It's not possible just to have the primary key to be null when we delete. So either the whole tuple is gone or nothing is touched. So entity integrity constraint cannot be violated using delete. The only possible violation in delete operation is referential integrity constraint. So let's take an example from the schema that we saw before. An example of referential integrity violation when we delete. So let's say there are 5 departments in the department table, D number 1, 2, 3, 4, 5. And in the employee table, there are 10 employees who are working in D number 5. So in the employee table, let's say there are 10 tuples with D number value 5. There are 10 employees working in D number 5. Now let's say for some reason, we want to delete D number 5, department number 5 from the department table. Let's say we are shutting down D number 5. So we want to delete D number 5, the tuple with D number value 5. We want to delete that tuple from the department table. Okay, so we go ahead and delete. But now what is the problem? There are still 10 employees in the employee table which is having D number value 5. But this D number 5 is now no longer available in the department table's D number column because we have deleted it from the department table. So now the D number value 5 is a violation of referential integrity constraint because now you have a value in the foreign key that does not exist in the primary key it is referencing. So this causes a foreign key constraint violation, also called referential integrity constraint violation. So now what can be done about this? So for those 10 employees that have D number value 5, what can be done about this foreign key violation? Here the DBMS has a number of options. The DBMS can use the restrict option, restrict or reject option, meaning the delete operation is rejected, it is cancelled. If the delete operation causes any violation of a constraint, then the delete operation is not allowed. So we do not allow the department to be deleted from the department table if we are using the restrict option. Another option is cascade option, which means what? We delete the tuple that reference the tuple that is being deleted. So what does that mean? If we are using the cascade option, when we delete D number 5, when we delete the tuple with D number 5 from the department table, what happens to the 10 employees which are also having D number value 5 in the employee table? Those 10 employees with D number value 5, they are also deleted from the employee table using the cascade option. So when we delete the D number 5 from the department table, all the employees in the employee table with D number 5 are also automatically deleted using the cascade option. Now you need to be careful when using the cascade option in delete because one delete in one table may lead to multiple deletes in other tables. So you need to be careful. There is a third option that is possible, which is the set null option, meaning the foreign keys of the referencing tuples are set to null. So again, going back to the example, if you use the set null option, when we are deleting the D number 5 from the department table, when we delete that tuple with D number 5, those 10 employees which are referencing D number value 5, they are set to D number null. Meaning those 10 employees, the D number value is set to null, meaning temporarily those employees do not have any department. Maybe later on they will be reassigned to other departments. But temporarily those 10 employees will have D number value null. This is the set null option. So these are three ways that the DBMS can use to handle a referential integrity violation. And one of these options must be specified during the database design. When you are creating the table using the create table command, you need to specify one of these options that will tell the DBMS how to handle a violation of referential integrity constraints. Now the update operation may violate different constraints depending on which attribute you are trying to update. So if you are updating an ordinary attribute, ordinary meaning it is neither the primary key nor the foreign key, then the only possible violation is domain constraint. And in that case, the update will simply be cancelled, be rejected. When you are trying to update a foreign key, then along with domain constraint, it may also violate referential integrity constraint. So let's give an example again from the schema that we looked at before. So D number, as we know, is a foreign key. It is referencing the D number of the department table. Now let's say in an update operation, the user is trying to update the employee's D number from 1 to 10. So he is changing the D number of a particular employee from 1 to 10. But remember, there are only 5 departments in the company, so there are only 5 D number values in the department table, 1, 2, 3, 4, 5. So therefore, a D number value 10 in the foreign key in the employee D number attribute is illegal, is invalid, correct? Because the foreign key can only take an existing value of the department's D number column. So, updating the foreign key may cause referential integrity violation. And how to handle that? Again, the DBMS has 3 options. It can restrict or reject, meaning it is not allowed, so that update operation will fail. Okay. So it will cancel the update operation. Lastly, if the primary key is being updated, then it is like you are deleting followed by an insert operation. And updating the primary key attribute may cause a violation of all 4 constraints. Let's see an example of this. Let's say you are updating the D number of the department table. So let's say we have D number value 5. From D number value 5, we want to update it to value 50. For some reason, we want to update the D number 5 to 50 in the department table. But there are 10 employees in the employee table which have D number value 5, the old D number value. So what can be done in this case? This will cause a violation. If you change the D number from 5 to 50, those 10 employees have the old D number value 5, so that's a violation of the foreign key constraint. Again, there are 3 ways for this to be handled. One is restrict or reject, meaning the update operation is not allowed because it's causing a violation. Another option is cascade. Cascade will do what? As you update the primary key from 5 to 50, the foreign key value of 5 is also changed from 5 to 50. So the primary key value changes from X to Y. The corresponding foreign key values are also changed from X to Y. So those 10 employees which used to have the D number value 5, they are also changed from 5 to 50, just like the primary key changes from 5 to 50. This is the cascade operation, the cascade option. And the set null option is also possible, set null, meaning what? When the primary key value is being updated, the foreign key is set to null temporarily, meaning those 10 employees which had the D value of D number 5, they are set to D number value null, meaning temporarily they will not have any department. Later on, they will be assigned to another department. So just like in the deletes, there are 3 possibilities, there are 3 options to be used in case of a referential integrity violation. In case of updating the primary key, if it causes a violation for referential integrity, then once again we have 3 options: restrict, set null, and cascade. Thank you.